Ever wondered why hypothesis testing holds such a pivotal role in Six Sigma projects? Well, the answer lies in the power of data-driven decision-making. Hypothesis testing, a statistical tool, allows us to draw conclusions from the data at hand, ensuring that any action taken is based on solid, reliable evidence. The process of hypothesis testing can be broken down into several steps. The first step involves choosing a statistic, a number that summarizes the data. This could be the mean, the median, the proportion, or any other relevant measure. Next, we create the null and alternate hypotheses. These are essentially statements about the population we're studying. The null hypothesis, denoted as H0, assumes there's no effect, while the alternate hypothesis, denoted as HA, suggests that there's an effect. Once we've set up our hypotheses, we compare our chosen statistic to a reference, a standard or benchmark, to help us decide whether to accept or reject the null hypothesis. Now, it's important to remember that errors can occur in this process. Type 1 error represents the probability of rejecting a true null hypothesis, while Type 2 error indicates the likelihood of accepting a false null hypothesis. To manage these errors, we often set a confidence level, usually at 95%. The symbols are used to represent these probabilities respectively. Choosing the right hypothesis test depends on a few factors: the type of data, levels of interest, the distribution, and the parameter under test. For instance, a proportion test is used when comparing sample proportion to a target, while a sample t-test is employed to compare means, especially useful for smaller samples. Running hypothesis tests is crucial because raw data alone can be deceptive. It's not just the numerical differences that matter, but also the context and variability within a process. By ensuring statistical significance, we guarantee that any decisions made are based on robust and reliable evidence. So, in a nutshell, hypothesis testing in Six Sigma projects is a way to make informed, data-driven decisions. It's a systematic process that involves choosing a statistic, setting up hypotheses, comparing the statistic to a reference, and making a decision based on this comparison. It ensures that any action taken is not just a shot in the dark, but a well-aimed arrow, guided by the light of robust statistical evidence.